Hello everyone, welcome to my channel. So today we'll be dealing with Python. Basically what we're doing is we'll go into computer science, Python for data analytics, DSE, that is for semester 4, FYUGP. So today we'll be dealing with data structures. The syllabus comes with data types in Python, modules, and NumPy library for arrays. It's pretty much an easy topic, so we'll be covering it all today. It will be a very interesting session, trust me. So I'll be sharing the screen one by one. So first up is data types. Python needs to know what kind of data it's dealing with, so it knows what it can do with it. So integers are whole numbers, floats have decimals, and complex numbers handle real and imaginary points, as you know. And booleans, they are simply on and off switches, like it gives output as true or false. And they help to keep things binary. Next we go is into sequence type. That is, think of these as a collection of items ordered in a specific line. So the main player here are strings, list, and tuples. The difference between them are like strings hold a text in double quotes mostly. Then list are highly flexible collection of uh, items wrapped in square brackets. You can add, change, or remove items anytime. That they are mutable types. Then when we come into tuples, tuples are wrapped in parentheses and they are strict cousins of list, we can say. Like once you create a tuple, it is immutable. You cannot change the contents. So perfect, it is basically perfect for data that should stay consistent. Like for example, if you take a GPS coordinate, the Earth's GPS coordinate will always be the same, so it should be consistent. So that is what immutable are. Then we have dictionaries and set. But what if order doesn't matter? Means as in like the others, if you don't want any order for it, you want to look things up quickly, you can enter it as a dictionary and set. So a dictionary works exactly like a real world dictionary or like a phone book we used to have before. So it maps out unique key to a value. It has both. It's a key value pair basically. That is a dictionary. Then a set. A set on the other hand is an unordered collection wrapped in curly brackets. And one golden rule is that no duplicates are allowed. So if you try to sneak a duplicate item into a set, Python will ignore it. So it is perfect for filtering out repeated data. So that is about. There is some brief note about what I have right now. Next, we'll be moving on to next topic. So next topic is modules. Moving on to a topic is as your code grows, jamming everything into a single file becomes a nightmare. Like when you know coding, like just imagine a lot of set of codes are all together, it would be confusing for sure. So a module is just a file containing Python code that's functions, variables, or classes that you can import into other files. There are different types of modules, and so these modules make it easier for us to code also. Like a function will be a definite set of problems that we need to do code, and there will be another module which will be having another function. So if you want, you can import these modules over and over again rather than typing it all over again. So there are two types of modules. That is, there are different types, and that there is inbuilt, and then there is user defined. So Python comes with a massive built-in garage of tools called inbuilt modules. Think of modules like math, random, or operation system. You don't have to write them, you just call them. But you can also create your own user-defined modules. Like so we'll be checking the user-defined modules. Let's say you create a file name like mymodule.py, and the code becomes like definition, function name, I'll give it as welcome, and in the parentheses, I'll give an argument name, and then return file welcome to team. So this is how we create a module, and you can save this. And if you want later on in another modules, you can use it there also. The next, the import statement versus from import. There are two types. You can import a module. So how do we actually use these modules? Like we have two primary ways. The generic import statement, like import statement, and specific from import statement. So if you look at the difference, we have import random, print random.ran int 1, 10. It's a random. But from import statement, from math import power. So from math was already a module that was created and we know. So that is how in the math module, we have already done programs to answer our output. So that is how from math import works. When you use a generic import, you bring the whole toolbox. Like to use a tool, you have to type the module name first, like math.sqrt. But if you need only one specific tool, you use from math import Py. So this grabs just that element, allowing you to use it directly. So it keeps your code clean, but be careful not to do accidental override over your own variables with the same name. So that is about modules in Python. Next up is NumPy, which stands for numerical Python. You might be wondering why we already have a Python is why do we need NumPy arrays? So the basic answer is speed and efficiency. Standard Python lists are flexible, but slow for massive math operations. So NumPy arrays are written in C under the hood, making them lightning fast and incredible memory efficient. So a one-dimensional array is essentially a single row of numbers, and they're often called a vector. And you can perform mathematical operations on the entire row at once without using loops. In multi-dimensional arrays, the real magic happens when we step into multi-dimensional, like 2D array or 3D arrays. A 2D array is structured exactly like a grid or like a spreadsheet organized by rows and columns, and NumPy handles these seamlessly, like allowing you to perform complex metric multiplications, structural data reshaping, and advanced analysis with just a single line of code. So, if you're diving into data science and like physics modeling, machine languaging, we use 2D array. So, thanks for watching the video. Drop your questions in the comment box, like, share, and subscribe. Thank you.